Alright, so we're going to finish up the notes on 5-2, and then I'll do another example, like example number 4 on here too, but you don't have to watch that one if you don't want to, if you already know what's going on with the other examples. So in these problems, we are at the very top of the page, we're given these triangles. And the first triangle we were going to look at is going to be this one. And we're going to use this, and I'm going to call this 1x, and then I'm just going to erase all the x's, because the x's are just going to cancel out anyway. So we're going to talk about angle 30 first. So 2 is the hypotenuse, 1 is the opposite, and 3 is the adjacent. So when I'm looking for the sine of 30, we're going to do the opposite over the hypotenuse, which is 1 over 2. This is one of those special 30, 60, 90 triangles that you should have learned in geometry that had all of the different ways that you can have with the x's. But once again, we're not going to worry about the x's because they're just going to cross out anyway. So the cosine of 30 is the adjacent over the hypotenuse, which is the square root of 3 over 2. And the tangent of 30 is the opposite over the adjacent, which is 1 over the square root of 3. So what I'm going to do now is I'm going to go back, and I'm going to fill in the top row. That was 1/2. We're not going to do 30, and we're not going to do 90 today. Square root of 3 over 2, and 1 over the square root of 3. So the next three are just the reciprocals. So the reciprocal of 1/2 is 2. The reciprocal of the square root of 3 over 2 is 2 over the square root of 3. And the cotangent turns out to be the square root of 3 over 1, which is just the square root of 3. Alright, so now I'm going to use this exact same triangle again. So here's 60, 30, and 90. This, excuse me, this was 2, this was x square roots of 3, but we don't need the x's anymore, and this is 1. But this time we're doing 60. 2 is still the hypotenuse, that never changes, but this time the square root of 3 is the opposite, and 1 is the adjacent, which means that the sine of 60 degrees is the square root of 3 over 2. The cosine of 60 is the adjacent over the hypotenuse, which is 1 over 2. And the tangent of 60 is the square root of 3 over 1, which I'm just going to call the square root of 3. I'm going to put those into my table. So this time in the bottom row, that's the square root of 3 over 2, 1/2, and the square root of 3. When I do the reciprocal, that's 2 over the square root of 3, 2, and the reciprocal of the square root of 3 is 1 over the square root of 3. Now to do the 45 row, we have the 45, 45, 90, which is x, x, and x square roots of 2. But I'm going to call this 1x and 1x, and then erase all the x's because I don't need them. It doesn't matter which 45 we use because we'll end up with the same thing anyway. So here's the hypotenuse, here's the opposite, and here's the adjacent. So the sine of 45 turns out to be 1 over the square root of 2. Now for those of you that remember how to rationalize, you multiply the top and bottom by the square root of 2, and so this is going to be the square root of 2 over 2. The cosine of 45 is going to be the exact same thing. And then the tangent of 45 is 1 over 1, which is 1, because the opposite over adjacent were both 1. Put that into our table, and we wind up with square root of 2 over 2, square root of 2 over 2, and 1. And if we take them before they were simplified, the reciprocal of the square root of 2 over 2 is just going to be the square root of 2 and the square root of 2. Because if I take the reciprocal of this, it's a lot easier. And then at the end, the reciprocal of 1 is 1. Now, one thing I want to point out to you in this order, the sign, we go basically 1, 2, 3 in the numerators. Everything has a 2 on the bottom. And in the cosine, it goes 1, 2, 3 in the numerator, going up, with a 2 always in the denominator. So these three things, along with 0 and 90, will come up a lot while we're going through trigonometry. One more example like the one we did before. We want the 6 trig ratios of angle B. Here's the hypotenuse. So I'm going to do 2 squared plus B squared equals 8 squared. Which means 2 squared is 4 plus B squared equals 64. Subtract 4, subtract 4. And when I do the square root of 60, that's 6 and 10, 2 and 3, 2 and 5. So these 2's pair up. So this becomes 2. On the inside is the 5 and the 3, which multiply out to be 15. This is 2 square roots of 15. Alright, so the sine of angle B, well, there's the opposite. So there's the adjacent. It's always important to look at which letters we're using. The sine of angle B is the opposite over the hypotenuse, which is 2 over 8, which reduces to be 1 over 4. The cosine of angle B is 2 square roots of 15 over 8, which is the square root of 15 over 4, because we reduce it again. The tangent of angle B is 2 over 2 square roots of 15, which is the 2's cancel, 1 over the square root of 15. Now I'm just going to do the reciprocals. The cosecant of angle B is 4 over 1, which is 4. The secant of angle B is 4 over the square root of 15, which doesn't change. The cotangent of angle B is the square root of 15 over 1, or the square root of 15. Let me know if you have any questions and start working on the 5-2 homework.